Hello everyone, this video is a continuation of chapter 7.2 on perpendicular lines. The objective of this section is to find out how the gradients of two perpendicular lines are related and also to find the equation of a line that is perpendicular to a given line. Let us first take a quick recap of the concepts that we have covered before today's lesson. So first of all, we have already learned how are the gradients of parallel lines related to each other. If the two lines y equals ax plus b and y equals to cx plus d are parallel, then the gradients of the two lines are actually equal. That means that a is equals to c. Whereas for gradients of perpendicular lines, if we say that y equals to ax plus b and y equals to cx plus d are actually perpendicular, then we say that the product of the gradients of the two lines is actually equal. That is equal to -1. That will mean that a times c is equals to -1. Alternatively, we can also see it as c equals to -1 over a. And we have mentioned that this we describe this as c being the negative reciprocal of a. So an example would be if we are given the lines y equals to 2x plus 1 and y equals to -half x minus 5. If they are actually perpendicular, then the gradients 2 and -half would actually multiply with each other to get -1. Another thing that we have covered previously is about finding the equation of a straight line. So one of the method is to use how we have done in Emaths, which is y equals to mx plus c. And the new method that I have introduced to you in Amaths is using this formula, which is actually derived out of the concept of gradients. So very often in Amaths, I would be using this formula instead. Let us now continue with our discussion in this chapter by taking a look at try 6 on your textbook, page 168. So in this question, we are given the diagram. The line joining P and Q is actually perpendicular to the line through R at the point F. So this is the diagram over here describes that situation. In part I, we want to find the equation of PQ. So to find the equation of PQ, which is this line segment here, we would need to first find out what is the gradient, and then after that, because we already know one of the points, either using P or Q, we would then be able to find the equation of PQ. So to find that gradient of PQ, we do y2 minus y1 over x2 minus x1, that particular formula, and then we achieve that the gradient is equals to 1. So using the formula that I have introduced to you into finding the equation of a straight line, we will substitute in the point either P or Q. In my case, I have substituted in the point P, okay, and then I will be able to get the equation to be y equals to x plus 2. Next, we take a look at part 2, where we want to find the equation of FR. FR is this perpendicular line. So in part I, we found that the gradient of PQ is actually equals to 1. So that will mean that because FR is a perpendicular line to PQ, the gradient would actually be equals to the negative reciprocal, so -1 over 1, and that is -1. So this is how I got this -1 here. Then, using the equation formula that I have introduced, the equation of FR would be y minus -1 equals to -1 times x minus 4. The point that I use is R because R is the only point, or rather the only set of coordinates that I know that lies on that straight line FR. So therefore, my equation would be y equals to -x plus 3. Next, we want to find out the coordinates of F. I want you to notice that F is actually the intersection point of the line PQ as well as the line FR. So in part I have already found out the equation of the line PQ, which is y equals to x plus 2. And then for the equation of the line FR, we have already found it in part 2, which is y equals to -x plus 3. Since we are trying to find the intersection point, we will solve these two equations simultaneously and achieve the coordinates to be 1/2 and 2.5 for the point F. And lastly, in part 4, we want to find the ratio of the length PF and also FQ. So PF is this length here and FQ is this length here. To solve this question, okay, instead of finding the exact length of PF and FQ and subsequently determining the ratio, let me introduce another method that actually requires the use of similar triangles. So take note of these two triangles that I have just drawn. These two triangles that I have just drawn are actually right-angled triangles. Right? The reason why I decide on right-angled triangles is because I would have horizontal and vertical lengths which are going to be easy to find. Okay, so I will first define this mark point over here to have to be x and having the coordinates of half and 1. The reason why I have half and 1 is because f has the coordinates of half and 2.5. So the x coordinate of f is half, so therefore the x coordinate of f is half, and then the x coordinate of x will have to be half as well. Okay, then the y coordinate of x will actually be equals to 1, following the y coordinate of p. Then for the green triangle that I have drawn, I would like to name this point here y, which will have the coordinates 3 and 2.5 by the similar concept that I have just mentioned for point x. These two triangles will actually be similar, right? We will not go about proving it, okay, until a later time, right? So now we will just take it that they are similar. So PF over FQ, which is the ratio that we want to find, I will express it as a fraction. Okay, so it will actually be equals to PX over FY. So PX refers to this line, horizontal line, and FY refers to this horizontal length. So the horizontal length would just be the difference in the x coordinates. So taking that difference itself, I will get 3 over 5. I can also consider, okay, taking the ratio fx over qy. And then after that, find out what is the difference in the y coordinates to determine the vertical length. The answer will definitely be the same. So therefore, my ratio for PF to FQ will be equals to 3:5. Moving on to exercise 7.2, question 8, we want to show that the triangle with the vertices P, Q, and R is a right-angled triangle. So in order for us to actually prove this, instead of using a Pythagoras theorem, okay, which will require us to determine the different length of the sides of the triangle, which can be rather tedious, we will make use of the fact that perpendicular lines have a product of gradients, or rather the gradient of the perpendicular lines will have a product of -1. Okay, so I am not too sure at this point whether will it be PQR, perhaps it could even be RQP, alright, or rather RPQ. That is also fine because this is after all just a sketch. Alright, so essentially, okay, what we want to determine is that as long as I have the gradient, two gradients of the two line segments, okay, to have a product of -1, I will be able to show that it is a right-angled triangle already. Alright, so I will proceed with finding out what is the gradient of PQ, which is -3/7, and the gradient of QR will be 7/3. Then I will find the gradient of PR, which is 2/5. So we see that, okay, the two gradients that will give us a product of -1 will actually be -3/7 and 7/3, because they are actually negative reciprocals of each other. So even if you cannot actually identify that they are negative reciprocals, even when you actually multiply the two values together, it will be equals to -1. So because the product is equals to -1, we will then be able to conclude that PQ and QR are perpendicular to each other, and hence triangle PQR is a right-angled triangle with angle PQR to be equals to 90 degrees. Okay, so for gradient PR, we are not going to use it to prove, okay, any right angle in the triangle. Alright, but we should still compute the gradient of all the 3 line segments that are available. Okay, I'm sure you'll be thinking whether I can use this way of solving to do Emaths instead of having to do Pythagoras theorem. Do take note that this manner of solving, right, requires, okay, coordinates to be introduced. Very often in Emaths, coordinates will not be given, right, for you to actually solve for you to prove a right-angled triangle. Alright, so I decided to use in this question the method of using gradient because I have coordinates being given. Alright, so that will actually make things simpler rather than having to find the different lengths, which can be a tedious task. We have come to the last question of chapter 7.2. Okay, so in this question 9, we are given that the point F is the foot of the perpendicular from the point A to negative 3 to the line y equals to 3x plus 1. This question did not provide you with a diagram, so let me run through with you how to draw this diagram. So question says that F is the foot of the perpendicular from A. So I drew in the point A first on the set of axes. Then after that, because F is the foot of the perpendicular from A itself, so from A I drew all the way towards the line y equals to 3x plus 1, and the intersection point would actually be the point F. Okay, so in part I want to find out what is the length of AF. So to find the length of AF, I will definitely need, okay, let me erase the highlights first. Okay, I will definitely need the coordinates of F. But in order for me to know the coordinates of F, sorry, let me just redraw the line back. In order for me to determine the coordinates of F, right, I would need to actually know what is the equation of the line AF so that I can solve simultaneously and look for that intersection F. So let us first begin the first few steps, which is to determine the equation of AF. To determine the equation of AF, I will need to know what is the gradient of the line AF, and that gradient of AF is negative 1/3 because y equals to 3x plus 1, okay, has a gradient of 3, so gradient AF will be negative 1/3. Then the equation of AF will be by using this formula I have introduced, okay, and using the point A to negative 3, I will solve that y is equals to negative 1/3 x minus 2 and 1/3. Okay, so I have first found out equation of AF. Next, okay, I will need to find coordinates of F. So coordinates of F can be done by solving the two equations simultaneously, and I will get x to be equals to negative 1 and y is equals to negative 2. So the coordinates of F will be negative 1, negative 2. Now that I have found the coordinates of F, I will then go on to apply my length formula to find out what is the length of AF. Okay, and my final answer will be 3.16 units when rounded to 3 significant figures. Now, taking a look at part 2, we want to find the coordinates of the reflection of A in the line y equals to 3x plus 1. So we see the line y equals to 3x plus 1 as like a mirror. Okay, so if I have the point A to negative 3 over here, whenever you stand right in front of the mirror image will be right in front of you as well. Okay, so being right in front means that it will be perpendicularly, alright, in that perpendicular line of action, okay, into the mirror, and then after going behind the mirror. So the point will somewhere be over here. Okay, your mirror image will always be of the same distance between the image to the mirror and also from the mirror to yourself. meaning to say that this distance here is the same as this distance. But we will not go about finding out what is that distance because it will be a very tedious task to do. What we will do instead, okay, is to notice that if I were to do this by drawing two triangles here, we notice that the two triangles are actually congruent. So what I can do instead, alright, they are congruent because this length, we mentioned that these two lengths are going to be equal. So because now that we mentioned that they are congruent, what I can do is to simply find out what is the difference in the x coordinate distance and the difference in the y coordinate distance between A and F, and translate that into the mirror image triangle. So by looking at the x coordinate 2 and -1, okay, we see that x actually decreases by 3 units, whereas when comparing the y coordinate, it is from -3 and then to -2, okay, and that is actually an increase by 1 unit. So now that we start from F instead, okay, because this is what, when I counted it, I was looking at A to F, so I will continue from F to the reflected point, okay. That's why I will take -1 and -2 here, and then I will actually -3 to the x coordinate because of the decrease by 3 units, and then after that I will +1 to the y coordinate because of the increase by 1 unit for the y coordinate. Therefore my answer will be -4, -1. Do you see how short working eventually becomes just by looking at the differences rather than finding out what is the exact length? We have come to the end of chapter 7.2, so please complete this homework exercise 7.2, questions 4, 7, 10, and 13. The deadline for this homework will be on the 22nd of June, Monday.